And next, this question is identical or similar concept with the question 3. For the question asks us to estimate the composition of a solution in which two isomers A and B are in equilibrium at 25 degrees centigrade, and so the Gibbs energy for the solution is at 2.2 kJ per mole. So for the composition of this species in the system, we can write as this one, where the fraction of B over A plus B, where again in this case, let's say this one is our container, so this A are able to convert to B, so that's why we have A and B composition, A and B species in our container. And the question asks us to predict the composition. When we talk about the composition, we need to know is how much is A and also how much is B. So that's why by using the chemical equilibrium concept, we can determine the composition of each species in our solution or in our system. So again, first thing first, we need to find the K, because K is indicate the product over reactant. So remember this one. So first thing first, we need to find the K. K is equal to the function of negative delta G naught over RT. So here our delta G is given by negative 2.2 kJ per mole. So we can convert it. It depends on you which unit you want to use. You want to convert the R constant, or you want to convert the delta G. It depends on you which method that you are comfortable. So here what I did is I convert this one into joule per mole. So we know that kilojoule is equal to factor of 10 power of 3. That's why we have 2200 joule per mole. So we times 3, so that's why we have 100 joule per mole. So from kilojoule per mole, I change it to joule per mole. However, you need to remember this one. Don't make mistake like this. And then over RT, R is a gas constant. R equal to 8.3145 joule per Kelvin per mole. And again, this we need to change it to Kelvin unit, where we know that in Kelvin we need to, here is our formula 273 plus S is our temperature in degree unit, in degree centigrade unit. That's why we have 298 Kelvin. We calculate it, we get 0.41. K equal to 0. By definition, we know that K equal to B over A, constant of B over A. Yeah, by definition. So you need to remember this one. So and then again we use this one, F fraction, the composition of concentration of B species. We can know is the fraction must be the fraction of species that we wanted. Let's say B is over total concentration of all the species in our solution. Now in our solution we have A and B. That's why the total concentration of our species is A plus B. So what we do is we divide everything. We divide the numerator and denominator with A over A, because A over A equal to 1. So here is one of relation that we need to know. Here we need to be a bit creative and play around with the concept we already learned in mathematical chemistry. So that's why in last we have B over A over A plus B over A, because we divide everything with A, and here it's full of our F. And then what we need to do next is we substitute, because we know that B over A equals to K, so we can substitute K here and here, and we know that A over A equals to 1. We know that everything is equal to 1. Here is the relationship that we should know. So that's why we have K over K plus 1. So in a previous calculation, we know that K, here we know that our K is 0.41. So we substitute this K with 0.41. That's why we have 0.41 over 0.4 plus 1. So that's why we have the ratio of B is 0.29. We can repeat this step. However, as we know that the total composition in our solution, the total composition is equal to 1. That's why we know that in our system we only have A plus B, constitution of A plus B, so equal to 1. So we know that B is 0.29. So that's why we know that we read the formula. That's why we get the composition of A is 0.71. So you can write it like this. So if we convert it into percentage unit, so we get 29% for B and 21% of A side. You also can write it like 0.29 and also 0.71. This unit is acceptable. Next, we move to question number 5. Number 5 asks us about the KC. It's about the KC. So okay, question give a case. The question is for question. Given this molecular name COCl2, a poisonous gas, decompose according to the equation. COCl2 gas will decompose to CO gas plus CO2 minus. Given the Kc is 0.083 mole per liter at 900 degrees centigrade, calculate the K for this reaction. So here is the Kc. Kc is constant at concentration, at certain concentration. So we already know that the formula of this one is K equal to Kc times with T over 12.027 K Kelvin, power of delta V gas. So first things first, what we need to do is we need to make sure our chemical equation is balanced. So as we see in this chemical equation, our equation already balanced. So 1 mole of COCl2 we produce CO plus Cl2. So both of this reaction and a product can reach equilibrium. So we have this one. So first we need to remember this one, delta V gas. Delta V gas is equal to product minus reactant. So here what we need to remember that this product is not concentration anymore. Here is the variable of the gas or the mole of the gas. So here we have 1 mole. Here we have 1 mole, 1. So that's why our product will be 2, because 1 is coming from CO and another 1 coming from chlorine gas. And then minus reactant. Now our reactant is we only have 1. See, there is a force gain COCl2. That's why 2 minus 1. So that's why we have 1. So next, we need to put all the value that we have in the equation. So the question already give us the KC. KC is 0.083 times with, now we need to convert this unit, this unit to Kelvin. That's why I put 273 plus 900 over this one is our constant, 12.07 Kelvin, power of 1. So we compute everything. So we get K equal to 8.1. Next question, question number 6. In an experiment to study the formation of nitrogen oxide in jet exhaust, N2 at 0.100 bar is mixed with oxygen gas at 0.200 bar, and the two gases are allowed to come to equilibrium with the product NO. In a reactor of constant volume, take K equal to 3.4 times 10 to the 51 at 800 K. So what is the equilibrium partial pressure of NO? So first thing first, we need to form the chemical equation for this reaction. So N2 gas react with oxygen gas, be NO gas. And then what we need to do is we need to balance this equation. So we balance it. So we know that one more of gas react, one more of nitrogen gas react with one more of oxygen gas, and we produce 2 more of nitrogen gas, nitrogen oxide gas. And then from there we can write the K, equation of K. We take the constant. So K equal to partial pressure of NO, power of 2 because we have 2 mole here, over PO2 in bracket partial pressure of nitrogen gas. And then one thing we need to remember that we need to know what is what value do we have at initial and also at equilibrium. So at initial we have 0.100 bar of nitrogen gas and also 0.200 bar of oxygen gas at initial, and we don't have nitrogen oxide at the initial partial pressure. And to change of it, so we need to look at our chemical equation. So now here, that's why we put S, because only we have the change is S, change is 1 mole F. Here we have 2 mole of nitrogen oxide, that's why we put 2S. However, the S is unknown value, so we need to calculate it. So and then the equilibrium partial pressure is this one is the initial change, that's why we put 0.10 minus S and 0.20 minus 2S plus 2S. And then what we need to do, we need to put all the value that we obtain here to this equation. So we have K equal to 3.4 and 10^-21. And then our partial pressure of nitrogen oxide is here is 2x, that's why we put 2x squared. And then 0.1 minus x and 0.2 minus 2x. And then we can compute this one. So here is the question that we need to know. 0.2 minus 2s, we can put it as 0.2 because this 2s is too small. And then if when it is too small, whatever number is too small, it will be almost to 0.2. Here is the relationship that we need to know, because it's very handy. Otherwise we calculate it, we have very long calculation. And then when we simplify it, we will get S equal to 4.12 times 10^-12 or negative 4.12 times 10^-12. So I ignore this number because it's negative. The partial pressure can't be negative, or the partial pressure must be in positive value. And then the question asks, what is the equilibrium partial pressure of NO? So we know that this NO is 2x. So that's why we replace the S with 4.12 times 10 to the 12, and then we get 8.24 times 10